going to quickly go over some of the review for Unit 1 problems. So I'm going to turn to page 3, and on page 3 I'm going to look at problem D. So I'm asked to solve for the inequality. So the first thing I need to do is I need to observe that this is an absolute value problem. So when I'm doing absolute value problem, I need to think about, I'm going to have a case A, case B. But before I even do case A, case B, I have to get the absolute value alone. That is key. The very first thing I need to do is get the absolute value alone. So I also have to pay attention to where is that inequality. So that inequality is right there. So that's the great divide, the great chasm. Takes work to get to the other side. That's where things stay balanced. So I'm going to use my order of operations, GEMDAS. And because I'm solving, I'm going backwards. Okay, so I'm going to ask myself, is anything being added or subtracted to this blue thing? Well, here I have an addition, and right between the 3 and the absolute value, I have multiplication. So I'm going to unadd, which means I'm going to subtract. So I'm going to subtract 4 from both sides of that inequality. That turns this into a 0. I did that on purpose. So again, I'm going to start writing from the right or the left side to the right, how we read. So I see a 3 times the absolute value of 2x minus 3 less than or equal to 6. So again, I'm going to look at my absolute value. It's not alone. I have this multiplication happening here. So I've looked, I've already taken care of the add and subtract. Now I have a multiply and divide. So I'm going to take care of that. I'm going to divide by 3 on both sides of that inequality. And that leaves me with the absolute value of 2x minus 3 is less than or equal to 2. Now my absolute value is alone. Do not skip this step. Write that step down. Then you're going to go to case A and case B. So case A, I'm going to do 2x minus 3, and then on case B it's also 2x minus 3. I like putting what I see here on my case B side. It doesn't matter. So notice this is exactly like this without the absolute value. But now on this one I have to flip my inequality because I've just changed my sign. So now same rules apply. What am I doing? I am trying to solve for my x. What is happening to my x? I have something being subtracted and something being multiplied. And I also have this great divide. So that means the first thing I have to do is either unadd or unsubtract. So I'm going to add 3 to both sides. So that gives me 2x is greater than or equal to 1. And now what do I have? I have multiplication, so I'm going to divide. And I have x is greater than or equal to 1/2. On this one here, I'm going to do the same thing. Again, I got to be very careful. So I'm going to add 3 to both sides. So that gives me 2x is less than or equal to 5. I'm going to divide both sides by 2. So I get x is less than or equal to 5/2. 5/2 is larger than 1/2. Here's 1/2. Here's 5/2. So I'm going to go back up to here. Is this an and or an or? This here is the absolute value is less than. So it's an and. For all intents and purposes, that means that it's going to be what they have in common. So it's going to be together. So this is going to be closed, and this is going to be closed because we have the equals. I'm going less than, x is less than, which is this way, x is greater than, which is that way, so that's an and in the middle. So set builder notation, not enough room to write that. The set of x such that, where's my x? In the middle. 1/2 is less than 5/2. So I'm going to copy that down. 1/2 is less than or equal to x, which is less than or equal to 5/2. Interval notation. I'm starting at 1/2. It includes it. And then I go all the way to 5/2. It includes it. So that is how I do problem D. Let's look at page 4. Page 4, looking at C. It's asking me to state the vertex, domain, range, interval is increasing, and then describe the end behavior. We're not going to do end behavior. So let's go ahead and graph this function. So I'm looking at this as y is equal to a, absolute value x minus h plus k. So I'm going to get my vertex. My vertex comes from the hk. So my vertex is, this is the same as x plus 0 because there's no h inside. So my h is 0 and my k is -2. So that means I'm going to go to 0, -2. So this is my a. That's like the slope on the right side. So the slope on the right side, down 1, right 3. Down 1, right 3. And I'll just do the mirror image on the other side, down and then left 3. Down 1, left 3. Okay? So my function gets drawn like that. So, what is my vertex? It's at 0, -2. What is the domain? The domain has to do with how wide is the function. I'm looking to my x-axis. If I were to put a point way out here, my x value is going to be at -infinity. So that's where it starts. If I keep going, it's touching the function, and I keep going, it goes forever this way. What is the value of x way out here? That's +infinity. So my domain goes from -infinity to +infinity. Remember, domain is how wide. And there are all these numbers, so this means all numbers. Okay, this means everything. That's what this means. It's not just this point and that point and that point. Range. Where is the bottom? Well, this keeps going down forever. So remember, I'm going to hold my stick on the y-axis. Where is the very bottom? Well, my y is going down forever because my function goes down forever. So y starts at -infinity. And as I'm going up, the very top is right here. There's no more function above y at -2. So it's -2, and it includes -2. So my input is all numbers. My output is from -infinity to -2. These are not points. They're all numbers or all numbers between. This is the same thing as saying y is less than or equal to -2, which means all values less than or equal to 2. Interval of increase. This is like domain. I want to know where is my positive slope. This is a positive slope. On that side, I'm going up. Where does it change? It changes right here at x is what? At x is 0. So it goes from negative infinity to 0 is where this is increasing. I'm going to go ahead and make this yellow. So all these x values, when I put them in, are making my y get higher. So my interval of increase is from negative infinity to 0. Okay, right here. X is 0. My interval of decrease, where do I have a negative slope? Down here. So this part here would be my x values of decrease. So where does it start? It starts where x is 0, and it goes all the way to where x is at infinity. These are always x values is what you look at. I'm going to stop the video here, and I'm going to continue with a couple more problems on another video.